Hi, welcome to Dissolve Chemistry. Today we will discuss about a very important topic. Not only exam point of view, it is very important to understand the various principles of chemical change, and it is one of the important topic that chemical industries are fond of. That is thermodynamics. So here mainly we are considering about chemical thermodynamics. Thermo means what? Okay, thermo means heat and dynamic means change. Means the transformation of heat energy into various other forms of energies and other forms of energy into in the form of heat energy. Say for example, we will take a very interesting example. You take a chemical substance. Okay, I will take as an example, single example, that how we can from different way we are going to draw the energy in different forms. Say for example, you take a methanol molecule, chemical as your methanol. Okay, we will take methanol as an example, CH3OH. Okay, so this methanol, what we can do, suppose if you just burn this, then what I can do is I can draw heat energy. Simply if we burn, then we can draw energy, and that we call it as combustion. Upon doing combustion or heating in or burning in presence of oxygen, if we do, then we can draw heat energy. Same, you might have heard this methanol is being used in the race cars. Okay, so there we can, when this same methanol when allowed to burn in the engine, okay, then we can do mechanical work. Means we can convert that into mechanical energy, or we can call it as work. Similarly, the same methanol gas, methanol, when you take and burn it in, or if you react in a fuel cell, you might have heard what is fuel cell. Fuel cell is the device where the chemical energy is converted into electrical energy without combusting the fuel. So fuel cell, if you take the methanol and if you react, so then you can draw electrical energy. And you might be thinking that if we drink, what happens? Methanol, if you drink, you will die because it is one of the class 1 poison. Okay, so now burning, we will get heat energy. If same burning, if you do it in the engine systematically, we can convert that into mechanical energy. And same methanol, when you take and react in the fuel cell, okay, at electrodes, if you react, so then we can draw electrical energy. Okay, means the same chemical energy we can convert into various forms by transformation in a different way. And this transformation of energy, energy from one form to the other form, one form to the other form, is the subject matter of thermodynamics. I think you might have understood that many reactions, or all the reactions, they got with certain energetics. Means we have to carry out in a particular conditions to bring that particular reaction. Particularly for every reaction we need energy to drive that reaction, or during the reaction there may be change in energy. We see that there is a liberation of energy. many things. The transformation of these different forms of energy, means from one form to the other form, is the subject matter of thermodynamics. And these laws of this thermodynamics are applicable to the transformation at macroscopic level, not at the microscopic level. Macroscopic changes what we bring, so to that we can, or transformation of energy at the macroscopic level we do, so then it is applicable, but not to the microscopic. That we will discuss in the limitations. Okay, so this is all about how the energy we are going to convert from one form to the other form. Various are there. You can take another example. I will tell you a very important example you can take. So that is thermal power generation. See here how the different thermal power generation as an example. I will illustrate you how we are going to do. See, in this thermal power generation, what it is being done is the energy stored in the form of chemical, that is coal. Okay, we are going to burn this coal. So from this coal, upon burning, okay, in presence of air, when we burn, we get tremendous amount of heat energy. And this heat energy is utilized to boil the water and generate the steam. Boil water and generate the steam. Okay. Now steam has got, with the molecules are elevated to higher temperature, and all that heat energy is carried by water molecules in the gaseous state. And now that energy, means molecules got with kinetic energy and they are moving, and this steam will move with energy, and this steam is made to rotate the turbines. Rotate the turbines, and these turbines, upon rotating, we are going to cut the magnetic field and we are going to generate the electricity. Okay, so that is how a chemical energy by heating, means by burning, we convert into heat energy. Heat energy is used to boil the water. We generated steam, which is a energy, more rich molecules, how they will get kinetic energy, and that kinetic energy we utilize to move the turbines, means we are converting that into mechanical energy, and mechanical energy in turn we are going to cut the magnetic fields, and then we are going to get electricity. So this is how a transformation of energy from one form to the other form is the subject matter of thermodynamics. Prior to going for various aspects, let me clear you what is the scope of this thermodynamics. This is very, very important at industrial level, as I mentioned previously. So that is the scope of this thermodynamics, particularly chemical thermodynamics. Scope, if we talk, the scope of this subject is that the thermodynamics will give you the information regarding either the given reaction is feasible under the given condition or not. Means it talks about feasibility of the reaction. Means under given conditions, under set of conditions, any reaction, either it is feasible or it is going to occur or not, that information we can gather from this thermodynamics. And second important point is it is applicable to the macroscopic objects, where the real change we can observe or we can visualize. Macroscopic object, it is applicable. Okay, it will talk about feasibility of the reaction and what are the energetics of the reaction we can talk. Okay, and these are all we can call it as scope of this thermodynamics. And what are the limitations? See, it is applicable only for macroscopic object. Okay, and means object in large scale, if it is there, then only. So these laws of the thermodynamics are applicable. We cannot apply the same thermodynamic principles to the changes at microscopic level. Okay, it is not applicable for microscopic objects such as few molecules or molecule atom, like that we cannot apply. Then the very important point is that it will talk about feasibility, means either the given process is going to occur or not. Okay, so that we can determine, but it is not possible to tell about with what rate that change will occur or reaction will occur, rate of the reaction, or with what speed the reaction will occur or the process will occur. That information we cannot get from the thermodynamics. This is one of the important limitations of this thermodynamics. Well, prior to going for various aspects of this thermodynamics, let me define some terms which we come across in this. See here, when you want to go for a thermodynamic study, so we will come across with various terms and we have to fix the certain things, and those terms we will discuss first. Okay, so among those very important thermodynamic terms are dynamic terms. Is first one is system and surrounding. System and surrounding, both we will define together. Okay, well, now you have taken a test tube. Consider a test tube in which you have taken two reactants and you are reacting. Now your test tube will be the system, and as you are doing reaction you may heat that, or sometimes what happens, as and when you add the reactants they will react and there is a liberation of heat is there. So now that heat is being exchanged with the surrounding. It is being a test tube which is having a walls, and it is being separated from what? Rest of the world by this walls, what we call. Okay, so we have taken the reactants and we reacted that. Okay, so now this test tube where we are doing reaction, and we are talking about what energetics means, either it has to be heated or heat is given out, all that study what we do, then this particular test tube will be acting as your system, and the rest of this, okay, the area around this test tube will be your surrounding we call. Okay, so I will still more systematize the definition of system. System is any part of the universe which is under thermodynamic study, okay, of which you are interested to know about the energetics or change of energies or transformation of energy in and out of the system, and that particular part of the universe which is under thermodynamic study, whatever it is, maybe a test tube, or maybe a beaker containing the two reactants, or maybe a flask, round bottom flask in which we are bringing out the reaction, or maybe your conical flask where you are doing titration. So wherever there is a change in energy or you are doing some thermodynamic study, now then that particular part of the universe we call it as what? System. Okay, that particular part is called as system. What is system? System is that part of the universe which is under thermodynamic study. We call it as system. Your system may be a beaker, maybe your test tube, maybe your round bottom flask, maybe your conical flask, or cup of tea containing hot tea. Okay, a cup of tea can also be acting as a system, and we will take this example while talking about various types. Okay, so a cup of tea is also an example of a system. Now these systems, what they do is they exchange energy with what we call, with what? That is nothing but your surrounding. Okay, surrounding means excluding this system which is being separated by an imaginary or a real boundary, rest of the universe we call it as surrounding. In fact, we cannot consider that it is going to exchange heat with the surrounding. Means suppose you are putting a fire somewhere and you are standing 100 meters away from that, and if you are expecting that system should exchange heat with you, it's not like that. Actually what happens, In fact, surrounding is that particular area around the system where actual exchange of the heat or exchange of the energy will take place with the system. That particular part is called surrounding, but we define as apart from system, rest of the universe is called as surrounding. But in fact, what is surrounding? Surrounding is that area, okay, which around the system where exactly exchange of the heat is going to take place. That is system and surrounding we have defined. Then next we will talk about various types of systems. Okay. Next we will talk about types of system. I think now you are clear with the term called system and surrounding. What is system? System is that part of the universe which is under thermodynamic study, we call it a system. And surrounding is rest of the universe which is under thermodynamic study. Rest, whatever it is there, that all is called as surrounding. In fact, surrounding is that part of the universe which is exactly going to exchange the energy with the system, that we call it as surrounding. Then next is types of system. Okay, we'll go first. Types of system. Now in that we will talk about what is, first one is open system. Open system. So what do you mean by open system? You take a beaker or test tube containing the reactants, or just you consider a beaker containing hot water. Okay, a beaker containing hot water. So now what it is doing, see, as you keep it for longer time, then what happens, the temperature of this hot water is going to reduce. Okay, it is going to decrease. Along with that, you are going to observe that over the hot water, water vapors are present over the surface of that, and which are being continuously exchanged with the surrounding. Okay, so means here heat is given out because temperature is going to decrease, meaning is what? Decrease in temperature will take place with time. Decrease in temperature. Meaning is what? Heat is lost to the surrounding, and as well as water vapors are escaping out from the beaker, meaning is what? Matter is also exchanged. Matter is also exchanged with the surrounding. So therefore, both heat as well as matter is being exchanged with the surrounding. Then such system we call it as what? Open system. The system where both heat as well as matter, if it is being exchanged with the surrounding, then it is called as open system. Then we will talk about second one is closed system. What do you mean by closed system? See here, in a hot water already we have taken in a beaker. So now if you close this with a watch glass, okay, now we have closed that one. Now what happens? The water vapors, whatever being evolved over the surface, okay, now what happens? They will hit the surface of this watch glass by which you have closed. Now then what happens? They will condense back and fall into the beaker. Okay, means matter is not going out. Okay, matter will not be exchanged with the surrounding, right? But after certain interval of the time, then what happens? The temperature will decrease, meaning is what? Heat is given out. Means heat is exchanged with the surrounding. Meaning is that the system which exchange only heat with the surrounding, means either it can absorb heat from the surrounding or give out heat to the surrounding, then that type of system we call it as what? Closed system. Okay. Then third type is, called isolated system. Isolated system. What do you mean by isolated system? The system which neither, if you take the same water, hot water in thermos flask, water or tea, you can consider anything which is taken in a thermos flask will be considered as what? A isolated system, because here what happens, a thermally insulated walls will be there with this thermos flask. So therefore it neither exchanges matter with the surrounding, okay, matter with the surrounding, nor it will exchange heat because it remains hot for longer time. You can see that one, either if you keep a hot tea in a thermos flask or hot water, hot milk, so its heat will be retained or it remains hot for longer time. Meaning is what? It is neither exchanging heat nor matter with the surrounding, and such system we call it as what? Isolated system. So like this we have discussed open system, closed system, isolated system. Now we will put together, okay, we will make out, you can summarize like this, okay. So this is the system, okay. System, if it exchanges both heat as well as heat and matter with the surrounding, then it is called open system, okay. If it exchanges only heat, not the matter, then it is called as closed system, okay. So when it exchange both heat as well as matter with the surrounding, then it is called as isolated system, isolated system, okay. This is how we can summarize the types of systems, okay. Rest thermodynamic terms we will discuss in the next video. Till then, bye, take care, and don't forget to subscribe our channel to see different topics of chemistry, okay. Thank you.